All right, we're thinking about some different parts of circles today. First of all, we know the center of the circle is, of course, the point, like P right there would be the center of our circle. We know a diameter stretches all the way across our circle, goes through the center. The diameter has to go through the center, and it has endpoints on the circle. And the radius is always the distance from the circle to the center. Well, all that's still true. If it says identify 3 radii, well, I have a radius NP. I have a radius LP. And I have a radius PQ. All of those are segments. Notice my segment symbol there. There is a diameter here all the way from N to Q, but it has to go through P, so our diameter is NQ. Now we have this new word, a chord. A chord is just any segment with endpoints on the circle. Notice ML is kind of a chord in the traditional sense. The endpoints are on the circle. Clearly, ML, both endpoints on the circle, that is a chord. But what a lot of people forget is that NQ, even though it's a diameter, it's also a chord. It has both endpoints on the circle. So also NQ is a chord. Okay, so a chord, any segment with endpoints on the circle. Now it says name a tangent to the circle and identify the point of tangency. Well, a tangent is a line, it's kind of like a glancing blow. It's a line that doesn't go through the circle, but instead passes by and only touches the circle at one point. That right there would be our tangent. So it looks like this is going to be tangent ST. And R, the point of tangency is the point where it does touch the circle. R, right there, R is our point of tangency. So point R is our point of tangency. A few theorems here. If a diameter is perpendicular to a chord, then it bisects the chord and the arcs. If a diameter bisects a chord other than another diameter, then it's perpendicular to the chord. Okay, so we're going back and forth here. A diameter, if it's perpendicular to the chord, then it bisects it. If a diameter bisects a chord, then it's going to be perpendicular to it. So it goes both ways. We essentially have the theorem and its converse. They're both true. So here it says find the length of x. Notice our diameter is perpendicular to this chord, which means that it bisects the chord, so x must also be 3. We want to find the measure of ORP. Well, notice how this diameter has bisected the chord, which means that it is going to be perpendicular to that chord. It's that simple. Check it out right here. The diameter is 14 inches. The chord AB is 8 inches long. How far is AB to the center of the circle? Well, notice and remember the distance from a line to a point is always going to be the perpendicular segment. So we know we're talking about that perpendicular segment right there. So it is cutting AB in half. They went ahead and filled in some of this information for us, but we could have drawn it just with this. The circle has a diameter of 14 inches. Chord AB, so somewhere on this there's a chord that is 8 inches long. And how far is this from the center of the circle? We know because we're talking about the distance from a line to a center, we're talking about the distance, we're talking about a perpendicular segment, and a perpendicular segment to a chord is always going to cut it in half. So 8 all the way across means there's 4 in each section. So we want to know the center, the distance, that we want to know this. We want to know x. I'm going to go ahead and mark that. Well, we can give ourselves a third side to this triangle. How can we give us that? Well, we just draw it. There we did. We draw that third side just like we have here. And what is the length of that? Well, that is a distance from the center to the circle. That is a radius. If the diameter is 14, that radius is 7. So we can find the third side. 4 squared plus x squared gives us 7 squared. 16 plus x squared equals 49. X squared is equal to 33. When we take the square root of that, we want to round to the nearest hundredth of an inch. So the square root of 33 rounded to the nearest hundredth would be 5.74. And we're talking about inches. So that is the distance to the center of the circle. That is the x value. Secondly, next theorem, the perpendicular bisector of a chord always will contain the center of the circle. Also, in a circle or congruent circles, chords equidistant from the center are going to be congruent. Any chords the same distance away from the center will be congruent, and congruent chords are equidistant from the center of the circle. Okay, so those go back to back, essentially converse of each other. If they're the same distance away, they're congruent. And if they're congruent, they're always going to be the same distance away from the center of the circle. So here we got a whole mess of stuff going on. It says find CD. We want to find the length CD if AP is 5 units, PE is 3 units. A lot of stuff going on here. Well, notice how we are given the marks that PF and PE are the same. PF and PE are both 3. Because that radius is 5, we know this radius is 5. And so I can see that this is a right triangle, and this is a 3, 4, 5 right triangle. So the missing side of these triangles is both 4. And because we have a perpendicular segment from the center of our circle to a chord, we know it's going to bisect that chord. And so if it's 4 over here, it's also 4 over here. They're the same distance away, so they're the same length. Both of these chords are 8 units. CD is 8 units, so is AB. I know they didn't ask for that, but we're just pulling it all together. We're talking about that theorem. We just said if they're the same distance away, they're going to be congruent, and we just showed that. That's what we just showed right there. Finally, some application. 2 identical circular pipes have diameters of 12 inches. Water is flowing 1 inch below the center of both pipes. What can be concluded about the width of the water surface in both pipes? Calculate the width. So we're just thinking about the width of the water all the way across where the water is flowing through the pipe. What is the width? Well, I know because a segment, that's essentially a chord, the flat surface. You know, we see the ripples right there, but just think of it as a flat surface. Perpendicular to that from the center, it's going to bisect it, so it's going to be equal. So if we can just find this piece right here, the third side of that right triangle, well, then we can double it to get the other side. This is 1 inch. Because our diameter is 12, we know the radius is 6. So I'm going to draw out that triangle for us. That's 6, 1. Looking for that missing piece right there. Pythagorean theorem, this guy, x squared plus 1 squared equals 6 squared. X squared plus 1 equals 36. x squared equals 35. When we take the square root of that, we get 5.92 when we round to the nearest hundredth. And we want to know the width of the water surface all the way across, so we need to double that. And all the way across, when I doubled that answer, got about 11.83. And we're talking inches here. So I did round to the nearest hundredth because they didn't give me any more specific values to round to. So I rounded 2 decimal places at the end.